Welcome back to 1.2 Linear Measure Part 2. This section is actually going to be talking about congruent segments. I'm going to start off, though, with a try problem from the last thing. So I know I'm just mixing everything up here, but I'm going to literally scoot that down so that you can get a better try problem, because the second example that I gave you with knowing the whole, I would like you to have some practice with that. So for this one, this is what we know. And they're going to ask you to kindly find YZ. So, writing out all of those steps, even the ones that seem dumb to write out, please pause your video and see what you get. All right, your answer is going to be that YZ equals 7 centimeters. So since I have centimeters here and 7 centimeters here, I need to include centimeters in my answer, okay? Awesome. Now let's move on to congruent segments. You have probably heard the word congruent before. What congruent is meaning is that it has the same length, basically. Has the same, well, okay. Back up a little bit. Congruent segments, specifically, have the same length. This means that whatever their measure is, it applies to both of them, okay? So that makes them congruent. Congruent means the same. It means duplicates, essentially, copies. So let me show you some congruent segments. I have a really cool situation because I can try to make them really, really congruent. The only problem is that, like, it does that. It, like, wait. Okay, whatever. So these are congruent segments, even though you saw the thing moving around is probably not exact. I'm going to name them A, B, and C, D, and I am told that they are both 2.9 centimeters. And that is why I know that they are congruent, because they have 2.9 centimeters as their measures for both of them. Because I know that they are congruent, I can mark them with a little dash like this. That is going to be our way of linking segments together to show that they are congruent, okay? And then when we are writing out AB is congruent to CD, when we write that out, I don't like that, but it doesn't quite mean equals, okay? So we want to put it as AB is congruent to CD. We can put those segment dashes over there. So that is our congruence sign. It's an equal sign with a little squiggle over the top. We're going to use that a lot. That means congruent. All right. Let me show you really quickly. If you have more than one congruent segment in a group that you're looking at, so, oh my goodness. Okay, you got to pretend there. So let's say I say, okay, these are congruent segments. I'm not saying that they're actually like in real life. I'm just saying for our reference, they will be. And we also have this one and this one as congruent segments. We've measured them and we're like, okay, they're the same too. So how are we going to mark that? Well, we can't mark it with just one because that is telling me that they're congruent to those two sides too. What we do if we have another pair of congruent sides is you're going to do a double dash. And then if you had a third pair, you would do the triple dash, okay? So that is how it's going to work. We're going to keep building up. The other thing that I want you to know is that these don't have to be in pairs. So I could have in my drawing this other picture or a piece here, I can have three things that are congruent to each other. It's not like they have to be like, oh, we're a couple. Okay, so you can have any number of things be congruent to others. Let's look at some ways that we might use this in our homework. We're going to be using it tons and tons as we continue on, but like, what might this look like when we're talking about betweenness? Okay, so so what if I told you to find PQ, and I gave you this picture. Oh my goodness. E for Emily. All right, you need to find the total of this here. You've got these dashes on the two parts, and then only one of them is labeled. If you see those dashes in something like that, you know that that means that this length, I'm going to do a different color, you know that this length is also going to have to be 2.3 inches because that's what it means to be congruent. I have the dashes, so it's congruent. If it's congruent, then they have the same measure, okay? And that is going to allow you to find PQ, and you move on from there, right? So why don't you do this one the rest of the way. It's going to be kind of a try problem. At the end, you should get 4.6 inches, and I'm pretty confident that you guys did well with that. Okay, the last example that I want to do is how it can get kind of fun. So what we will see over and over again in geometry is we will learn the basics, and it's 2.3 plus 2.3, but we will usually reach a point where we say, oh my gosh, well, what if we just like made expressions these pieces instead of just using numbers? Like, what if we added variables in, basically? So if I had this and this one was 3A, BC was 14, and AC was 5A minus 4. They could ask me quite a few questions actually with this. They could say, what is A? They could also say, what is AC? Or what is AB? For all of these, you have to figure out what A is. So B is between A and C. So that means that I can say AC must be equal to AB plus BC. Awesome. I know all of those pieces, so I can just plug all of them in right now. So I'm going to have 5a minus 4 equals, AB is 3a, and then BC is 14, so plus 14. This is going to be one of those multi-step equations that we worked on a lot last year. So just switch into algebra mode for me here. When you see something like this, you're going to have 5a equals 3a plus 18, and then you subtract 3a from both sides so that you've got everything together. 2a equals 18, divide by 2, and I get a equals 9. So the answer, if I was asked what a was, is 9. If I was asked what AC was, I would have to do 5a minus 4 and then plug in the 9 for the a. And 5 times 9 is 45, minus 4 would give me 41. So that's AC, if they asked. And then AB, same kind of deal. Plug in 9 where we see A. That makes it 3 times 9, and that is 27. So, what do you think? Don't be mad, but I'm going to do one more try problem because I know that you probably are a little rusty on your algebra, okay? So we're going to do one more that's like that. Actually, we're not. I'm just kidding. Sorry. I changed my mind. Okay. That's all. I will work with you on this more on Monday. Have a good day. Have a good weekend. Bye.